Hello everyone, my name is Geeta Swami from College VV80. I am from CSCC. Today I am going to discuss about my digital logic design seminar, and the topic is full subtractor by using half subtractor. So we need to implement this full subtractor by using half subtractor. So first in this seminar we are going to learn about what is meant by a full subtractor, what is the function it performs, what are the different ways to construct a full subtractor by using all the basic gates like AND gates, OR gates, and some other gates like NAND gates, NOR gates, XOR gates. So we will also discuss about what is meant by design procedure, what is the procedure required to construct this full subtractor. So we will all discuss this in this topic. So talking about full subtractor, first of all we need to learn what is meant by a full subtractor. So the full subtractor is nothing but the definition is the full subtractor is it is a combination circuit which subtracts 3 bits at a time. The full subtractor, it is a combination circuit which subtracts 3 bits at a time. So this is the definition of full subtractor. So now we are going to see about different various steps we acquire to design this full subtractor. So this is known as a design procedure. So coming into this design procedure, there are 4 steps in design procedure. So let us learn every step. Step 1 is nothing but we need to identify the number of inputs and outputs from the given specifications. From the given condition, we need to identify what are the number of possible inputs and what are the number of possible outputs. So the step 2 is we need to write the truth table that defines the required relationship between the inputs and outputs. So in the second step, we are going to draw the truth table which gives the interconnection between the both inputs and outputs, how they are connected. So this gives us an idea about what is the process we are doing, what is the system we are following in this procedure. So the step 3 is nothing but from the truth table we need to obtain simplified Boolean expressions for each output in the function of input variables. So it may be we will acquire the K-map method for simplification of Boolean functions to obtain the simplification of Boolean functions. So it may be in the form of sum of min terms or product of max terms. So the step 4 is nothing but to draw the logic circuit and verify the correctness of design. So the step 4 is nothing but to draw the logic circuits. Here we are going to learn the full subtractor in various using various gates. So we will see it later. So coming about now step 1. According to the definition, here we have seen that it is a combination circuit which subtracts 3 bits at a time. So from the input itself, from this sentence itself, we have clarified that we need 3 inputs, and we also know that as subtraction operation is performed, we will get 2 outputs, that is nothing but difference and borrow. So it was mentioned here the step 1, number of inputs required is 3, that is let us assume that A, B, C, and number of outputs is 2, that is difference and borrow. So the step 1 is successfully completed, and now going into step 2, the step 2 is we need to derive the truth table that it defines the required relationship between input and output. So the truth table is here. So A, B, C are the 3 inputs and difference and borrow is the output. So as they have given that it subtracts 3 bits at a time. For 3 bits there are possible combinations of 8 from 0 to 7. So we all written all the 8 combinations and their difference and borrow. So here we can see that 0 minus 0 is 0 and 0 minus 0 is 0. Difference is 0 and borrow is also 0. For example, 0 minus 0 is 0 and 0 minus 1 is nothing but difference 1 and also borrow 1. 0 minus 1 is difference 1 and borrow 1. So 0 minus 1, difference 1, borrow 1. So 1 minus 0 is 1 and also in the borrow 1 is present. So likewise we are going to draw the truth diagram for all the combinations which are present, all the 7 combinations which are present in the input sides. So this is about step 2, and step 3 is obtain the simplified Boolean expressions. So to obtain this simplified Boolean expression, we are going into the method of K-map. So K-map gives us the simplified Boolean expressions of the output. So the simplified Boolean expression, step 3. So as we know that we are going to write this as sum of minterms. So for sum of minterms, the output will be 1. So if we are drawing difference, we are drawing a k-map for difference, we will consider the difference, and we will consider the output 1. As we are following sum of minterms, the output will be 1. So the output 1 is for the combinations 1, 2, 4 and also 7. So here it is written 1, 2, 4 and 7. So as we all know that k-map, so there are 3 variables are present, a, b, c. So here it is, here the k-map is drawn, and from this we can obtain the simplified Boolean expression as a bar b bar c plus a bar b c bar plus a b bar c bar plus abc. So this a bar b bar c plus a bar b c bar plus a b bar c bar plus abc can be written as a xor b xor c. When we simplify this a xor b xor c, we would get the above this difference equation. So this is the simplified expression by using the k-map. So we are getting the output as a function of input variables abc. So likewise we have now we have done for difference. Similar method we follow for also borrow. So as for borrow also, we are writing in the form of sum of minterms. We will consider 1 as an output. So 1 is an output for different combinations like 1, 2, 6, 3 and 7. So the simplified function also by following the similar procedure for k-map which we have followed for difference. So for borrow also, the simplified function is a bar c plus a bar b plus bc. This is the borrow expression. So step 3 is also successfully completed. Now coming to the step 4 of design procedure, we need to draw the logic circuit. So as we have completed, we got the different expressions for difference and also borrow. So now we need to draw these expressions in form of a logic gate. So before drawing into the logic gates, we need to see the different implementation. So this is from the book. We are drawing the logic diagram for the difference. So a bar b a b c will be multiplied and added here. A bar b bar c, a b bar c bar, a bar b bar a b bar c bar. So all these will be added and this will be the difference equation as mentioned here. The difference equation is this one, and we would get the same output as we discussed above. So similarly we would get same for the borrow too. The borrow equation is also a bar c plus a bar b plus bc. This is the expression for borrow by using basic gates, that is AND gates and OR gates. So now we will implement this by using half subtractors. So drawing the logic circuit, we know that the circuit of half subtractor is this one. So the definition of half subtractor is it subtracts the 2 bits at a time. The full subtractor subtracts 3 bits, whereas half subtractor subtracts only 2 bits. So by considering so to design this half subtractor we follow the same design procedure. We will identify the number of inputs and outputs. We will draw the truth table, and also we will form the simplified Boolean expressions and draw the logic circuits. So after following all the 4 steps, we would get the logic diagram of a half subtractor is this one. So now let us use this half subtractor for construction of full subtractor. So after construction, the full subtractor looks like this. So the full subtractor circuit is this one, and there are 2 XOR gates, 2 AND gates and 1 OR gate. So this whole circuit at a time produces the both difference and also borrow. As here we discussed, the difference and borrow is present, we are getting the both difference and borrow in 2 different methods, but here we would get difference and borrow in single circuit by using this full subtractor. So here, as we discussed above, the half subtractor looks like this. This is XOR gate, 1 NOT gate and one AND gate. So same is present here, XOR gate, NOT gate, AND gate, XOR gate, NOT gate, AND gate. So this is one half subtractor and this is one half subtractor. Totally there are two half subtractors required for the construction of full subtractor. So now we will draw this full subtractor circuit by using universal gates called NAND gates and OR gates. So by using NAND gates, the full subtractor circuit looks like this. So this is the full subtractor circuit by using NAND gates. So this is the full subtractor circuit. So here we used only NAND gates to implement both difference and also borrow. So that expression derivation for the borrow is given as here. So this expression is expression for borrow by using, this is implemented by using NAND gates. So the full subtractor by using NAND gates looks like this. The difference is common, A bar, A XOR B XOR C, and the borrow we would get as this one. So now we have completed the full subtractor using NAND gates. Let us see the full subtractor using NOR gates too. The full subtractor looks like this when it is implemented with the NOR gate. I hope you are clear with this photo. So at every gate we are drawing the output, the expected output. So at 7th gate what is the expected output, and at the 9th gate what is the expected output. So this is the full subtractor by using NOR gates. So the both difference and borrow is given by the both NOR gates, and full subtractor is implemented by this one. The difference and borrow, the expressions for difference and borrow is can be seen here. So this is in the form of product of max terms. As we discussed in sum of min terms, the borrow here, the borrow is product of max terms. So the both product of max terms or sum of min terms, both are correct. So this is about the full subtractor, that the procedure for full subtractor, what are the different types of different connections and different various methods to implement full subtractor. So this is about the summary of the seminar. So thank you everybody.